Good morning, students. Very good morning. Welcome to the GATE class. Today, we are going to see the session Transformers. Today, we are going to see the session Transformers. Previously, we have discussed DC motor and DC generator. Now, we are moving to Transformers. Electrical machines are combinedly called as DC motor, DC generator, transformer, AC motor, AC generator. Transformer, there is no AC or DC type, it is AC type. There is no confusion like DC generator, DC motor, AC generator like that. It is only belongs to the AC family. There is no confusion in transformer. Transformer is purely a AC device. Today we are going to talk about what is transformer and the MCQs questions based on the transformer, which is useful for your GATE preparation. Let's move on to the MCQs. I'll share my screen now. The first question, the secondary winding of which of the following transformer is always kept closed? Transformer is having two winding, primary winding and secondary winding. We all know that. Depends upon the number of winding, it is called as a step up or step down transformer. If the primary winding is have more number of turns compared to the secondary winding, it is called step down transformer. For example, primary winding is more number of turns. It is going to supply the flux to the lower number of turns in the secondary. It is called step down. In vice versa, primary is having less number of turns when compared to the secondary. In this case, it is called as step up transformer. Depends upon the applications. We are having so many transformers like auto transformer, a current transformer, voltage transformer. Actually, we are not calling it as voltage transformer. It is called a potential transformer. Power transformer, step up transformer, step down transformers. Depends upon the application, various applications. We are having the transformers names. The secondary, here the question is secondary winding of which of the following transformer is always kept closed? They are asking that secondary winding of which of the following. We are given so many transformers, that is 4 transformers is given as a choice: current transformer, voltage transformer, power transformer, step down transformer. Among these 4 transformers, which transformer the secondary winding is closed? Let's see the explanation. And current transformer, if the current transformer secondary is not shorted, when unused and kept open, then it can develop a very high voltage across secondary, which may damage transformer insulation. Among the above transformers, current transformer, voltage transformer, power transformer, step down transformers, current transformer must be the secondary winding of the current transformer must be always kept closed, or else it will damage the transformer insulation. So the answer will be current transformer. You can look, then we can move on to the second question. Second question, if the supply frequency of a transformer increases, that is, for example, supply frequency is varying or you are increasing the supply frequency, the secondary output voltage of the transformer will be what? If the supply frequency of a transformer increases, the secondary output voltage of the transformer will increase, decrease, remain the same, any of the above. That is, if you change the frequency, what will happen to your voltage, output voltage? For this, you must know the relationship for voltage and frequency in transformer. In this case, whether the output of the voltage is increase, decrease, remain the same, or any of the above. Any guess you can explain, or else we can go for the explanation part. Yes, remains the same. If you change the supply voltage or supply frequency, in that case also the supply output voltage will be remain same. There won't be, for example, 50 voltage is there, it won't be affect. It will be same. You look for a while. it will be remain the same. The transformer is a static device that changes voltage from one side of its coil to the other at the constant frequency. We all know that there is no rotating part in the transformer. That's why it is called as a static device. It is called a static device because it is not having any rotating part. Then frequency does not change because of the working principle of the transformer based on mutual induction principle, which happens without any change in frequency. The definition itself, transformer is a static device which transforms one form of energy to another form without change in frequency. From this, it is concluded that remains same. The answer will be, the output voltage will be remain same. If you are okay with this question, we will move on to the next one, power transformer question. As I said, depends upon the application. We are having lot of transformers, power transformer, auto transformer, step up transformer, step down transformer, like this. Now we are move on to power transformer question. Power transformer are designed to have a maximum efficiency. When at what efficiency we are developing a power transformer? Full load, 50% load, 80% load, at no load. We have to be clear at which percentage of the efficiency the power transformers are designed. Any guess? You can say it is full load or 50% load or 80% load or no load. Let's move on to the explanation part. It is at full load. Full load, once the power transformer is clearly loaded, that is fully loaded, that case only the power transformer is designed. So power transformer are designed to have a maximum efficiency at full load. The power transformer are used for transformation of step up device. That is, mostly it is used in the case of stepping up. Hence, they are not directly connected to the consumers. Therefore, load fluctuation is very less, because once it is directly connected to the consumers, in your home, you will switch on AC or fridge. Another home, they will switch on AC and mixer grinder. Another home, they will switch on a refrigerator and grinder. In this case, load fluctuations will be there, but power transformer are not directly connected to the consumers. Once it is not directly connected to the consumers, load fluctuation is very less. So the power transformer can operate at full load. So it is understood that power transformer can be designed when the efficiency at full load. Let's move on to the fourth question. The open circuit test in a transformer is used to measure. We know that transformers are having OCC, that is open circuit test, and SCC, short circuit test. They are talking about open circuit test. Open circuit test in a transformer is used to measure what? Either it is a copper loss, winding loss, total loss, or core loss. We know that we are having a lot of losses like hysteresis loss, eddy current loss, copper loss, iron loss, winding loss, total loss, core loss. The open circuit test in a transformer is used to measure what? They are asking. OCC test is carried out to conduct what? Copper loss or winding loss or core loss. OCC test and SCC test must be very important. In what part they are used to conduct what test? To measure what loss? This test must be dedicated. So let's show the explanation. Core loss. As the transformer is open circuited, there is no output. Once it is open, obviously the output must be open circuited. OCC is output must be open. So the copper loss is neglected as the no load current is very less. So OCC test is carried out for what? For core loss. Let's move on to the next question. Flux. Leakage flux in a transformer depends upon the value of. We all know that flux transmission is from primary winding to the secondary winding by the rule of mutual induction. Mutual induction principle, it is transferring the flux. In this case, there will be a possibility of getting the leakage flux. The leakage flux in the transformer depends upon the value of. How can you find out there is a leakage flux? Either frequency, mutual flux, load current, applied voltage. Any guess you can answer, or else we'll move on to the explanation part for better understanding. Leakage flux in a transformer depends upon the value of what? Frequency, mutual flux, load current, or applied voltage. Any guess? Okay, let's move on to the explanation part. Load current. The transformer core flux is the difference of primary flux and the secondary flux, which are opposite to each other in direction. It is obviously primary flux and secondary flux are opposite each other in the direction because it's a mutual induction principle. Once the flow is opposed by the opposite flow. So the primary flux passes through the core, remaining becomes leak flux. Yes, once the fluxes passes through the core, the remaining becomes the leakage flux. The same is the case of secondary flux. Now the flux is directly proportional to the voltage and current. So the core flux remains constant. So the load current, that is the leakage flux in the transformer, depends upon the value of load current. How much current is consumed by the load determines the leakage flux. Take a look for a while, then move on to the next question. Any doubt you could ask me, or else we can move on to the next question. Yes, we'll move on to the next question. Lamination. Sixth one. Question number 6. Lamination of the transformer core is made up of. We all know that transformer must be laminated to avoid the electrical leakage like that. So they're asking lamination of the transformer core is made up of cast iron, silicon steel, aluminium or cast steel. Lamination of the transformer core is made up of cast iron, silicon steel, aluminium or cast steel. What will be the lamination? What will be the good lamination for the transformer core? Let's move on to the explanation. Silicon steel. Yes, silicon steel must be a good lamination because silicon steel are used for electrical transformer core and core of other electrical devices for the following reason. Not only for the transformer. Yesterday in DC generator class also I have explained silicon steel is a good lamination for armature. Here they are asking silicon steels are used for electrical transformer core and the core of other electrical devices for the following reason. Why we are preferring, yesterday we talked this as a stalloys. This one only silicon steel. Why particularly we are using silicon steel? It is having low hysteresis loss, high permeability, virtually eliminated aging, high resistance. This must be another question. What are the properties of silicon steel as a lamination? It is having low hysteresis loss. Hysteresis loss is avoided, so it is a better lamination for what? The transformer, not only the transformer, for electrical machine, all the electrical machine, motor, generator also. It will having a high permeability, then virtually eliminated aging. For example, we can observe some aging purpose in this one. It is totally eliminated. High resistance. It will offer a high resistance. So, silicon steel is a better choice for lamination purpose. Let's move on to the next question. Breather. Breather is provided in transformer. Breather, conservator and all, we know that. Breather is provided in a transformer to what? We must be aware about the construction of transformer. Breather is provided in a transformer to absorb moisture of air during breathing, provide cold air in the transformer, the filter of transformer oil, none of the above. Breather, what is the breather purpose? Breather purpose is absorb moisture of air during breathing. The primary function of the breather is to absorb air moisture during breathing. We all know that breather and conservator is a part of construction in the transformer. The function of breather is absorb moisture of air during breathing. The primary function of the breather is to absorb air moisture during breathing. I'll show you the construction part of the transformer so that it will be more clear. I'll show you so that you must know what is the breathing part, what is the thing and all. So it will be more clear for better understanding.
Transformer is an electromagnetic static device in which input is in form of.
Understand properly, my dear students, so that you will be more clear about the construction part, what it is, for what it is used. Once you know the construction and usage of the particular construction part, it will be more clear for answering the MCQs.
Of electrical energy, and output is also in electrical form. Also, the input and output both are in alternating form. Primarily, transformers are used to change level of voltage and current. For example, in case of step-down transformer, the input high voltage is transformed to a low voltage, whereas the magnitude of current is increases because input and output power has to be remain same. Working of a transformer can be understood by taking a simple example of a small piece of wire carrying current when it is connected to a battery. As a result, a magnetic flux gets set up around the conductor. If another piece of wire comes in the vicinity of this flux, an electromotive force is get induced in the conductor, which we can see here from deflection in needle of a galvanometer. But after some time, deflection becomes zero. Because both conductors are stationary, means there is no relative movement between them. This is known as dynamically induced EMF. Further, we can also experience that EMF is again induced in the second conductor when we remove battery. This is because of a reduction in flux density around the first conductor, and the second conductor try to oppose this change in flux as per Faraday's law of electromagnetic induction. The magnitude of EMF induced is given by E2 is directly proportional to d phi by dt. This electromagnetic coupling between the two conductors can be improved by two methods. Number 1, by using coil on both sides instead of using single wire. This results in increase of flux. Number 2, by using a magnetic core between the coils, which gives low reluctance path to the flux and improve magnetic coupling between the coils. As you can see here, in this case, coil of left side, or we can call it primary coil, has lesser number of turns than the coil on right side, or we can call it secondary coil. And the transformer is called as step-up transformer. In this case, voltage which induced on secondary coil V out is higher than voltage which is applied V in on the primary coil, whereas the current get reduced as the power has to remain constant. Similarly, when primary coil has more number of turns than the number of turns in secondary coil, the transformer is called as a step-down transformer, and the voltage induced on the secondary side, V out, is less than the applied voltage V in on primary side. The core which is practically used in a transformer is actually not a solid core. It is made up of number of thin sheets of metal called laminations. This type of construction is used to reduce eddy current loss, which occurs inside the core when it carries changing or alternating flux. As core is used to provide a low reluctance path to the magnetic flux, but the core is subjected to circulating electric currents. These circulating currents, called eddy currents, produced heating and energy losses within the core, results in decreasing the transformer's efficiency. The circulating current is produced mainly due to EMF induced in the iron core, as it is constantly being subjected to the changing magnetic field set up by the external sinusoidal supply voltage Vn. To reduce these unwanted power losses, thin steel laminations is used to construct the transformer core. Laminations are made up of highly permeable material, that is silicon steel. These laminations are assembled together to build a solid core. The resistivity of the steel sheet itself is high, reducing the eddy current losses by making the laminations very thin. The thickness of these laminations is vary between 0.25 mm to 0.5 mm, and as steel is conductor, laminations are electrically insulated from each other by a very thin coating of insulating varnish or by the use of an oxide layer on the surface. The problem with the construction which is so far discussed here is that the two windings are well separated from each other, and there is considerable reduction of magnetic coupling and hence the efficiency of the transformer. This disadvantage can be overcome by using constructing core like this, in which the two windings are bring close to each other, thereby improve magnetic coupling between them. Hope now you have a little bit idea about principle of working of electrical transformer and about its construction. We will discuss it in more details.
Now it must be little bit clear, that is how the transformers are construction part of transformers, how it is working. Little bit knowledge we will gain through this animation video. Any doubt you could ask me now. Any doubt in this session you could ask me. Or else let's move on to the next question. So far we have stopped till breather. Next question, which of the following losses varies with the load in the transformer? Once we are changing the load, which of the following losses varies? Because when losses occurred, that must be the same, right? But this losses changes when load varies in the transformer. What is a loss? Core loss, copper loss, both core and copper loss, none of the above. Which one? Let's see the explanation, then I'll show you what are the losses. Copper loss. Copper loss varies with the load in the transformer. I have given the explanation also. Copper loss is due to ohmic resistance of the transformer winding. We know that because of the ohmic resistance, copper losses occurred. I square R is also a loss. IR is also a loss. IR will be the I square R IR is also a loss, but commonly it is I into I, current into the double the current. So we are not calling it as IR, we are just calling it as I square R. Primary winding I square R and the secondary winding is I square R, but it notation is given for the primary and secondary winding individually. Where I1 and I2 are the current in the primary and secondary winding respectively, R1 and R2 are the resistance in the primary and the secondary winding respectively. It is clear that copper loss is proportional to the square of the current and the current depends upon the load, and the copper loss in the transformer varies with the load. It is understood the resistance value is changed from the above equation. It is not commonly I square R. It is I1 square into R1 for primary winding, I2 square into R2 for the secondary winding. So it is understood that from the equation, resistance value is changed. So what loss is this? Copper loss. So copper loss only varies with changes in the load. Take a look for a while. We can move on to the next question. Okay, we'll move on to the next question. A transformer transforms. A transformer transforms what? Current, voltage and current, frequency or voltage. What it will be. We all know that which transform the current, it's a current transformer. Voltage, it is voltage transformer. We'll see transformer transforms voltage and current. Yes. It's called a potential transformer and a current transformer. It is called a potential transformer and current transformer. The transformer is a static device that is used to convert the voltage or current to a higher or lower level. That is, transformer is a static device which convert voltage or current from step up or step down. Depends upon the application. I already said we are having various transformer. That is distribution transformer, auto transformer, tap changing transformer. Basically belongs to the family of power transformer with respective unique features. Depends upon the applications. Then in an instrument transformer, voltage and current on one side of the transformer comparatively high. So what the transformer transforms? Transformer transforms voltage and current. Voltage transformer is known as a potential transformer. Current transformers, current transforming the transformer transform the current is known as current transformer. Move on to the next question. Transformer cores are laminated in order to. Why we are laminating the core transformer cores? Why? To reduce hysteresis loss or reduce hysteresis and eddy current loss or minimize eddy current loss or copper loss. Which one? Let's see the explanation. Minimize eddy current loss. In a transformer, the eddy current loss is proportional to the square of the diameter of the core. In order to avoid the losses created by the eddy current, the core must be laminated. Any doubt? So to minimize the eddy current loss, we have laminated. I'll show you the losses in transformers now, so that you will get a better idea to answer for the losses in transformer MCQs.
Hello everybody, this is Digital Blackboard by Sachin. Transformer. We are discussing all the topics of transformer. In this video, we are going to discuss about losses in transformer.
Losses in transformer is a very important topic when considering to the MCQ point. Let's have a brief discussion about the losses in transformer so that it will be much more easy for you to answer for all the MCQs based on the losses in transformer. So please clearly watch this one. After this session, I will forward the MCQs to your mail. You better attend so that you will get some more knowledge about the transformer topic.
So let's start. So as we know that there are three main parts in transformer: an iron core, then primary winding, and then secondary winding. In an iron core, there is existence of flux, and in primary winding and secondary winding, there is flow of current. So losses in transformer takes place because of these two parameters, that is because of flux and because of current. So there are two types of losses in transformer. First loss takes place in the iron core, is called as iron loss or core loss, and second loss which takes place in the primary and secondary winding is called as copper loss. Now as the primary and secondary winding is made up of copper wire, it's mainly called as a copper loss. So these two losses are there, iron loss and copper loss. We are going to discuss each loss in detail. So first of all, we will discuss about the iron loss. So it is clear that iron loss is taking place in an iron core. And in the iron core, there is existence of flux. So but natural, the losses because of flux is nothing but iron loss. Now why the losses because of flux is taking place? So we know that transformer works on AC supply. So when we provide AC supply to the transformer, it magnetizes the core. So after magnetization of the core, there is existence of flux, and the nature of that flux is alternating. Then as the nature of this flux is alternating, this flux is changing with respect to time. So alternating flux or changing flux is there in the iron core. So because of this alternating field or because of this alternating flux, the losses takes place in the iron core. The first loss is called as eddy current loss. Now what is this eddy current loss? So as the flux is alternating, it links with the iron core. When the flux links with the iron core, according to Faraday's law of electromagnetic induction, there is an induced EMF in the iron core. And as there is induced EMF in the iron core, there is short circulating current in the iron core. And this short circulating current is called as eddy current. And losses because of this eddy current called as eddy current loss. So the first loss in the iron core is nothing but eddy current loss. Okay. So what is the reason for eddy current loss? So alternating flux links with iron core, then it produces EMF in the core according to Faraday's law of electromagnetic induction. EMF produces short circulating current in the core called as eddy current, and losses due to eddy current is called as eddy current loss. So this is the first iron loss. Now as we know that the nature of the flux is alternating. So before magnetization of that iron core, all the molecular magnets or dipoles in the iron core are in random direction. But when the core gets magnetized, all the molecular magnets or dipoles get aligned in the uniform direction. But as the magnetic field is reversible or alternating, so this dipoles has to change its orientation after every half cycle. So the change in flux, it means nothing but changing the direction of molecular magnets or direction of dipoles. So because as this dipoles has to change its orientation after every half cycle, there is again some energy loss takes place, and this energy loss is called as hysteresis loss. So there are two types of iron losses, that is eddy current loss and hysteresis loss. So iron loss or core loss, there are two types of iron loss or core loss. First is eddy current loss and the second is hysteresis loss. Both the losses are because of the flux. So eddy current loss as well as hysteresis loss depends on flux, and flux in transformer remains constant from no load to full load, and that's why iron loss or core loss is called as constant loss. So what is the reason called iron loss is a constant loss? Because this losses depends on flux, and flux in transformer remains constant from no load to full load. That's why this loss is called as constant loss. So the next loss is called as copper loss. So this copper loss takes place in the primary winding and secondary winding. So as we can see, there is current flowing in the primary winding as well as in secondary winding. So when current flows in the primary winding and secondary winding and secondary winding having resistances. So let R1. So R1 is the primary winding resistance and R2 is the secondary winding resistance. I1 is primary current and I2 is secondary current. So but natural, when current flows through a resistor, again power loss takes place. And the formula for that power loss is I square R. So I1 square R1 is the primary copper loss and I2 square R2 is the secondary copper loss. So addition of these two losses called as total copper loss. Okay. So copper loss takes place in primary winding and secondary winding. These losses are because of current in the primary winding and secondary winding. So these losses depends on current. And current in transformer depends on varying load condition. Because according to the load condition, the current of primary and secondary will vary. And that's why the copper losses are called as variable loss. Okay, so copper loss is called as variable loss. So why copper loss is called as variable loss? Because these losses depends on current and current in transformer depends on varying load condition, and that's why copper loss is called as variable loss. Okay, so in this video we have discussed the topic that is losses in a transformer, and one thing is very important, that both the losses are power losses and result in the form of heat, and therefore because of these two losses the temperature of transformer or the temperature of machine increases. So I hope you understood this topic very clearly. So please.
So it must be clear that is why it is the iron losses are called constant loss, why the copper loss is known as the variable loss. It is understood from this video, so that we can add some more MCQs in the losses area. We'll switch on to the MCQ part. Okay, the essential condition for parallel operation of two single phase transformer is that they should have the same KVA rating, turns ratio, polarity, or both 2 and 3. The essential condition parallel operation, we know that for compensation purpose we are using parallel operation. The essential condition for parallel operation of two single phase transformer is that they should have what and what. Any idea about the answer? KVA rating, turns ratio, polarity, both 2 and 3. We'll see the explanation. Both 2 and 3, that is turns ratio and polarity, is the answer for this question. The same turns ratio are required so that open circuit secondary voltage of the transformer are closely matched in order to avoid excessive circulating current when the parallel connections are made. If the transformer are connected with different polarities, then the 2 EMF induced in the secondary winding, which are parallel, will produce a short circuit current between the transformers. Look for a while, we will move on to the next question. Okay, we'll move on to next question. A transformer has negative voltage regulation when its load power factor is. What will be the answer? A transformer has negative voltage regulation when its load power factor is lagging, leading, unity, or any of the above. So what will be the answer? Leading. Why it is leading? Why it is leading? For leading power factor, load, the secondary voltage voltage increases slightly with the increase in the load current. Thus, for leading power factor loads, the regulation is negative. When the load is capacitive, It must be V2 is greater than E2, so it is called a leading. The main purpose of performing short circuit test in the transformer to measure what? The main purpose of the performing short circuit test in the transformer is to measure copper loss, core loss, insulation resistance, or total loss. We will see the explanation. Copper loss. Again and again from the video, it is clear that copper loss, iron loss, the same questions repeatedly. Merely you will get two or one, at least one question from the losses area in the gate, in the electrical machines part. So be aware about the losses part, much more clear. Yes, look for a while. We'll move on to the next question then. Yes. The short circuit test. Previously we saw OCC test, right? Now short circuit test. The short circuit test in a transformer is performed on what side? Low voltage side or high voltage side, or either 1 and 2, both 1 and 2. OCC is kept, we have done on output side. Now we are asking SEC test is carried out in high voltage side. That is high voltage side. A short circuit test is conducted to find the copper loss. It's calculated under the assumption that core loss is neglected. When SE test is conducted on LV side, it would require a larger voltage to get the rated current, and the core loss cannot be neglected in this case, and wattmeter does not give the copper loss alone. Therefore, to get accurate result, the test is done on HV side. Clear for you? I'll show you what a short circuit test.
A power transformer is usually employed for the purpose of converting power
See the
at a fixed
full
frequency.
view of the transformer. This how the transformer looks like. Now we are going to see short circuit or full load test of a transformer, so that question will be more clear.
From one voltage to another. If it is used for converting power from a high voltage to a low voltage, it is called a step-down transformer. The conversion efficiency of a power transformer is extremely high, and almost all of the input power is supplied as output power at the secondary winding. For confirming the specifications and performances of an electrical power transformer, it has to go through short circuit test, full load test on transformer. In this video, we'll learn about short circuit test and their procedure. Objectives of short circuit test: to conduct standard open circuit tests in order to find the parameters of the equivalent circuit of a transformer. Evaluate the regulation and efficiency of the transformer at a given load. Check the excitation characteristics of the transformer. Short circuit test on transformer. The connection diagram for short circuit test on transformer is shown in the figure. A voltmeter, wattmeter, and an ammeter are connected in the high voltage side of the transformer as shown. The voltage at rated frequency is applied to that high voltage side with the help of a variac of variable ratio autotransformer. The low voltage side of the transformer is short-circuited. Now with the help of variac applied voltage is slowly increased until the ammeter gives reading equal to the rated current of the high voltage side. After reaching at rated current of high voltage side, all three instruments reading, voltmeter, ammeter, and wattmeter readings are recorded. The ammeter reading gives the primary equivalent of the full load current IL. As the voltage applied for full load current in short circuit test on transformer is quite small compared to the rated primary voltage of the transformer, the core losses in transformer can be taken as negligible here. Let's say voltmeter reading is VSC. The input power during test is indicated by voltmeter reading. As the transformer is short-circuited, there is no output. Hence, the input power here consists of copper losses in transformer. Since the applied voltage VSC is short-circuit voltage in the transformer, and hence it is quite small compared to rated voltage. So, core loss due to the small applied voltage can be neglected. Hence, the voltmeter reading can be taken as equal to copper losses in transformer. Let us consider voltmeter reading is PSC, where RE is equivalent resistance of transformer, if ZE is equivalent impedance of transformer. Therefore, if equivalent resistance of transformer is XE, these values are referred to the high voltage side of transformer, as because the test is conducted on high voltage side of transformer. These values could easily be referred to low voltage side by dividing these values with square of transformation ratio. Therefore, it is seen that the short circuit test on transformer is used to determine copper loss in transformer at full load and parameters of approximate equivalent circuit of transformer. Thanks for watching.
Now it is clear that what is a short circuit transformer. Transformers what we have discussed, it is clear that today's class we have discussed what is transformer, then what are the losses, construction of transformers, what is OC test and SC test. Based on this, we have discussed some MCQs. If you have any doubt, you could ask me. Okay, thank you so much. We'll end up today's session. All the very best.